So I got really excited last summer when New Horizons flew by Pluto, and I wanted to learn a little bit more about that. And so I started reading up on it a little bit, and I was really intrigued by what I found. Now, this is going to be the presentation of a biochemist. I am not an astronomer. I'm summarizing some of the things that I've discovered, mostly reading little NASA pages and stuff like that. But it all goes back really to the Kuiper Belt. So let's take a look at the Kuiper Belt. Now, I first learned about the Kuiper Belt from creationists. And this is kind of what I learned. Number one, comets are unstable. The tails of the comet, which you see in the picture there, are caused by solar wind blowing off parts of the comet nucleus. So every time the comet goes by the sun, it gets a little smaller, which would suggest that, well, they can't keep on orbiting the sun because eventually they'll just disappear, right? The sun will just blast them into nothing. So that would suggest that comets, or short-term comets at least, have a limited lifespan. So if there are comets, which there are, then they couldn't have been orbiting for billions of years. So how would we explain this in a conventional model? Scientists would say that the short-term comets came from something called a Kuiper Belt. The long-term comets come from something called an Oort cloud. But my creationist authors would assure me there is no evidence of either one of those things. So comets indicate that the solar system is probably not billions of years old. At least that's what I was told. All right, so let's check this out. So the solar system in 1990, the year I graduated from high school, looked something like this. Now, of course, this is very stylized, and these things aren't all that close together, and the sun is really too tiny. But the point here is that there was a ninth planet called Pluto. So what happened to that ninth planet? Even before it got demoted, which we all know it did, we knew that Pluto was pretty weird. First of all, it had a very weird orbit. The orbit is extremely off-center. It crosses over the orbit of Neptune. So there's a point at which it's actually closer to the sun than Neptune is. So we already knew that Pluto was weird in that way. We also knew that Pluto was weird because it rotates the opposite direction of most of the planets. So most of the planets rotate counterclockwise. Pluto rotates clockwise, and it rotates much slower than the Earth does, as you can see in the animation here. The axis of Pluto is also heavily tilted, so Earth's axis is tilted a little more than 20 degrees. Pluto's axis is tilted 123 degrees, making the rotation look something like this model right here. As we think about sort of this Kuiper Belt thing that's supposed to be the source of the short-term comets, it's kind of helpful to think in less specific terms and more in terms of things that are just out past Neptune. So this is another term that we see in the literature, not just Kuiper Belt objects, but Trans-neptunian objects, things that are orbiting the sun past Neptune. And it turns out there's a lot more of them than we suspected. So in 1990, when I graduated from high school, there was one, Pluto, right? But by 92, cameras and telescopes had advanced sufficiently that we could actually find others. So by 95, there were 33 Trans-neptunian objects known. By 2000, 372. By 2005, more than 1,000. By 2010, 1,250. And then as of April of 2016, almost 1,500 Trans-neptunian objects. Space is looking a little crowded there. If we look at the distribution of roughly the average distance from the sun, the semi-major axis, we find that there's actually two groups of these things. There's one group that orbits slightly less than 40 astronomical units from the sun, and then there's another bigger group that orbits with an average of less than 45, say 42 or 43 astronomical units from the sun. So these aren't just randomly distributed out there. There's some very specific groups of things out there, which is why some of them have been called Kuiper Belt objects and others have been called just Trans-neptunian objects. Several of them have moons. So obviously Pluto has the moon Charon that we already knew about, plus Kerberos, Hydra, Styx, and Nix. Eris, which is the next biggest Trans-neptunian object, has a moon called Dysnomia. Makemake, which just recently was discovered to have a moon that's now called MK2, probably will get a cute name eventually. Quaoar has Wewat, and Orcus has Vanth. These are all quite large trans-Neptunian objects with their own moons. And this is the image of Makemake showing that tiny little smudge there, which is the moon MK2. So what does it all mean? Well, honestly, creationist astronomers have a lot of interesting data to work with. So when we're thinking about the structure of the solar system, there's some really interesting patterns here, especially those classes of trans-Neptunian objects. The old claim that there's no evidence for the Kuiper Belt, that's not correct. Now we might modify that argument about comets in this age of the solar system, but I don't think we're going to be able to just say, well, there's no such thing as a Kuiper Belt. So we have some work to do. Just saying that God could make the solar system any way he wants to, that's not really satisfying. It's not really satisfying because, well, he could make the solar system any way he wanted to. But he didn't. He made it the way he did. So why is it that we have these distinct bands of trans-Neptunian objects? What does that mean? Is that some pattern that we're supposed to take a lesson from? Whatever it means, God already knows, right? God receives the glory. Just by virtue of the fact that we went out there to check it out. And I'm really excited to have seen the day when NASA beamed back images of Pluto to Earth. And I can't wait to see what New Horizons does next.